This is the IELTS listening test. You will hear a number of different recordings, and you will have to answer questions on what you hear. There will be time for you to read the instructions and questions, and you will have the chance to check your work. All the recordings will be played once only. The test is in 4 parts. Pause. At the end, you will be given 10 minutes to transfer your answers to an answer sheet. Now turn to Part 1. Part 1. In this part, you will hear a telephonic conversation, and based on that you will get 10 questions. First, you have some time to read questions 1 to 6. Now listen and answer questions 1 to 6.
Good morning, Greenfield City Council Environmental Projects Department. This is Lisa speaking. How can I help you today?
Hello, my name's Josh Patel. I saw a poster at the community centre about a cleanup event along the river next month, and I'm interested in volunteering. Could you give me some information about what's involved?
Absolutely, Josh. We're always happy to welcome new volunteers. Our next major cleanup project is scheduled for Saturday, the 12th of May. We're focusing on the east bank of the River Meadow, as that area has accumulated a lot of litter over the past year.
I see. Is there a minimum age for volunteers?
Yes, volunteers must be at least 16 years old. Anyone under 18 needs to bring a parent or guardian's signed permission form.
That's fine. I'm 22, so no problem there. What time does the event start?
We'll be meeting at 8:30 a.m. at the main entrance to Meadow Park. The cleanup usually runs until around 1 p.m. We provide a short briefing at the start and offer refreshments at the end.
Do volunteers need to bring any equipment?
We supply all the essential gear: gloves, bin bags, litter pickers, and high-visibility vests. However, we do recommend that everyone wears sturdy closed-toe shoes and comfortable clothes so that you don't mind getting dirty.
Good to know. Do we need to sign up in advance?
Yes, it's important to register online by May 8th so we can make sure we have enough equipment for everyone. The registration form is on the City Council's website. Just search for Greenfield Cleanup.
Will we be working in teams?
Yes, we split everyone into groups of 4 to 6 people, each led by an experienced team leader. This helps keep the work organized and makes it a bit more fun.
Is there a contact number I can call on the day if I'm running late or get lost?
Absolutely. The event coordinator's mobile number is 7893145221. You can call or text that number anytime during the event.
Before you hear the rest of the conversation, you have some time to read questions 7 to 10. Now listen and answer questions 7 to 10.
That's useful. Will refreshments be provided for volunteers?
Yes, at the end of the morning, we'll have a picnic lunch set up at the park. There will be sandwiches, fruit, snacks, and a choice of hot or cold drinks. We try to cater for all common dietary needs, but if you have any allergies, please mention them on your registration form.
That's thoughtful. What happens if it rains?
We always hope for good weather, but the event goes ahead unless conditions are dangerous, like heavy thunderstorms. If it's just light rain, we recommend bringing a waterproof jacket and a hat.
Is there any training required before the event?
We send a short online safety video to all registered volunteers a few days before. It covers safe lifting, how to handle sharp objects, and basic first aid information.
Will participation count towards any volunteering awards or certificates?
Yes, everyone who takes part receives a certificate of participation by email within a week of the event. This can be used for community service hours at school, university applications, or your CV.
That's excellent. Is there parking available near Meadow Park?
Yes, there's a free public car park on Willow Lane, just a 5-minute walk from the entrance. If you're taking public transport, several buses stop nearby.
Thanks so much, Lisa. This sounds like a great initiative.
Thank you, Josh. We look forward to having you on the team. Remember to register by May 8th and you'll receive a confirmation email with all the final details.
I'll do that this afternoon. Have a good day.
You too. Goodbye.
That is the end of part 1. You now have half a minute to check your answers. Part 2. In this part, you will hear a monologue. A person is giving an orientation to a group of people. First, you have some time to read questions 11 to 15. Listen carefully and answer questions 11 to 15.
Good morning, everyone, and thank you for attending today's orientation session for our community recycling program here in Northwell Town. This initiative began just over a decade ago as a small-scale local effort. Since then, it has grown into a full-fledged program involving more than 3,000 households and nearly 100 business partners. Our primary goal is to promote sustainable habits and reduce the amount of household waste going to landfills. We operate across several neighbourhoods, and each area has a designated drop-off zone where residents can leave items for recycling. You'll receive a schedule and location guide in your welcome packet, so you'll know exactly when and where collections take place in your area. Let's talk about what we accept. Many people are surprised to learn that we now take a wide range of items, not just plastic and glass. That includes small electronic devices, textiles, and even cooking oil, provided it's sealed in appropriate containers. As part of the initiative, every participant receives a recycling toolkit. This includes color-coded bins, instructions on sorting, and a calendar of events. We also provide biodegradable bags for food waste, which can be collected weekly. We ask that you rinse any containers before placing them in the bins. This helps reduce odor and discourages rodents from entering collection areas. Now let's go over some basic etiquette and safety tips.
Before you hear the rest of the conversation, you have some time to read questions 16 to 20. Now, listen and answer questions 16 to 20.
Before I wrap up, I'd like to answer a few common questions and clarify a few things that people often find confusing. Let's start with plastic types. We only accept plastics labeled with numbers 1 to 5, which are the most commonly recycled forms. Unfortunately, we cannot process number 6 or 7 plastics at this time, as they require a different recycling stream that isn't currently supported in our region. Next, you might be wondering what happens to everything you recycle. Well, it's all sorted at our local eco centre, where materials are processed and either reused, sold to recycling companies, or turned into new products. For example, your old t-shirts could be transformed into insulation for housing. Another question we often hear is about missed collections. If your recycling isn't picked up on the scheduled day, you can report it via our website or mobile app. It's important to do this within 24 hours, so we can arrange a follow-up. Some people are also concerned about how to handle hazardous materials like batteries and paint. We do not collect these in the regular bins. Instead, we offer a quarterly hazardous waste collection drive, which is announced on our website and social media. Lastly, if you're interested in getting more involved, we're always looking for volunteers to help educate the public, attend events, and promote best practices across neighbourhoods. Thanks again for being part of this important effort. We're glad to have you with us.
That is the end of part 2. You have half a minute to check your answers. Part 3. Part 3 is an academic discussion between a student and a professor, or between two students. You need to listen to their conversation and answer questions based on that. First, you now have some time to read questions 21 to 25. Now, listen and answer questions 21 to 25.
Good morning, Annika. I've just finished reading the first draft of your engineering project proposal. You've done quite a bit of work already.
Morning, Dr. Linton. I'm glad to hear that. I wasn't sure if I'd managed to narrow the focus enough.
I think you're getting there. Your topic, autonomous public transport systems in urban areas, is both timely and technical. You've done well outlining the current developments.
Thank you. I wanted to explore how self-driving technology could be applied to city buses, not just cars. There's a lot of coverage on autonomous taxis, but far less on mass transport.
That's true. And it's an area with growing investment. Now, you've mentioned case studies in Singapore, Stockholm, and Los Angeles. Why those three cities?
Each has launched pilot programs involving driverless buses in the last 5 years. I thought they represented different approaches, Singapore being tech-driven, Stockholm focusing on sustainability, and LA more on reducing congestion.
That's a smart comparative angle. Are you planning to use data from these trials?
Yes, where available. Stockholm has published ridership stats and user satisfaction surveys. LA has limited data, but there are academic papers analyzing the routes and safety incidents. Singapore's Land Transport Authority has released some technical specs and cost reports.
Be careful with data compatibility. Different cities might measure outcomes differently.
I'll try to normalize the indicators, looking at average route length, energy consumption per kilometer, number of incidents, and user trust ratings.
That makes sense. How about technology types? Are the buses using the same systems?
Not really. Stockholm uses electric buses with onboard sensors and GPS, while Singapore's pilot used a combination of LiDAR and AI navigation. LA's program relies more on centralized traffic control input.
Interesting. That could feed into your analysis of system reliability and failure points.
Yes, exactly. I want to highlight how varying technical architectures affect deployment success.
And how are you handling the issue of safety?
I've devoted a section to that. I look at accident rates, emergency override protocols, and reaction times. I found a recent study comparing manual versus autonomous driver responses. It showed that while machines react faster, they struggle with unpredictable human behavior.
That's a key insight. What about cost analysis?
I'm comparing initial investment versus long-term savings. Autonomous buses are expensive to implement, but savings on wages and improved efficiency could balance things out. Singapore's pilot, for example, suggested a break-even point after 7 years.
And have you considered ethical or legal concerns?
Yes, I've added a section discussing accountability. Who's responsible in a crash? The manufacturer, software developer, or city? There's still no clear global framework.
Good. That brings in a social dimension. Lastly, are you suggesting a city for future adoption?
Yes, I recommend Edinburgh for a future pilot. It has challenging topography and weather, ideal for testing autonomous performance in real-world urban conditions.
That's well argued. Make sure you support your choice with specific environmental and logistical data.
Will do. I'll also be adding a table comparing the 3 cities and 1 hypothetical scenario for Edinburgh.
Before you hear the rest of the conversation, you have some time to read questions 26 to 30. Now listen and answer questions 26 to 30.
Now, have you thought about your presentation? You'll need to deliver it in week 11, right?
Yes, I'm presenting on Tuesday afternoon at 2 p.m., I believe. We have 8 minutes, correct?
That's right. 8 minutes plus 2 minutes for questions. Keep it focused and avoid technical jargon unless you explain it clearly.
I've planned a 4-part structure: introduction, key case study comparisons, technology analysis, and final recommendations.
Sounds good. What are you using to open?
A brief video clip from Singapore's driverless shuttle launch. It gives a real-world feel and shows the tech in action.
That'll work, as long as it's short, 30 seconds maximum. People's attention spans are limited.
Of course, I'll follow it with a graph comparing safety incident rates between human and automated systems.
Visuals are excellent, but don't clutter your slides. Try to keep the total number under 7.
I've got 6 slides planned, including 1 infographic and 2 charts.
Perfect. Also, remember that your file needs to be uploaded by Monday at 4 p.m. the day before.
Noted. I'll upload it Sunday to be safe. Do I need to submit speaker notes too?
No, just the slides and any embedded media. Make sure your file format is compatible, PDF or PowerPoint.
Got it. Thanks again for your help, Dr. Linton.
No problem. You've clearly put a lot of effort into this, Annika. Looking forward to your presentation.
That is the end of part 3. Now you have 30 seconds to check your answers. Part 4. This part is a monologue where a person gives a seminar on a topic. You need to listen and answer all the questions at once. First, you have some time to read questions 31 to 40. Now, Listen and answer questions 31 to 40.
Good morning, everyone. Today's lecture will focus on an area that is increasingly significant in our discussions about sustainability: the role of microorganisms in supporting and maintaining our environment. Often overlooked due to their microscopic size, microbes are in fact fundamental to the planet's ecosystems and are now being harnessed for a wide range of sustainable applications. Let's start by discussing what we mean by microorganisms. These include bacteria, fungi, protozoa, and viruses, though for environmental purposes we primarily focus on bacteria and fungi. These tiny organisms are present in soil, water, air, and even within other living organisms. Their capacity to break down organic matter and recycle nutrients makes them essential to ecological balance. One of their most important roles is in biogeochemical cycles, such as the nitrogen cycle. Certain bacteria, like those in the genus Rhizobium, live in the root nodules of legume plants. They convert atmospheric nitrogen into ammonia, a form that plants can absorb. This process, called nitrogen fixation, reduces the need for synthetic fertilizers, which are costly and environmentally damaging when overused. Similarly, microorganisms are key players in decomposition. When plants and animals die, microbes break down their tissues, returning carbon, nitrogen, and other elements to the soil. Without this process, ecosystems would be overwhelmed by organic waste, and nutrients would not be recycled. Moving on, microbes are now being used in bioremediation, a process that uses living organisms to clean up environmental pollutants. For example, after oil spills, certain species of bacteria can degrade hydrocarbons found in petroleum. These bacteria consume oil as a food source, converting it into harmless byproducts like carbon dioxide and water. This method is considered much safer and more natural than using chemical dispersants. Bioremediation is also being applied to clean up heavy metals and pesticides in contaminated soils. Some bacteria and fungi can immobilize or even transform toxic substances into less harmful forms. In this way, microbes help rehabilitate damaged ecosystems, making land and water usable again. Now let's talk about waste management. In composting, for instance, microbial action is responsible for breaking down food scraps, yard waste, and manure into nutrient-rich humus. This is not only an efficient way to recycle organic material, but also reduces the volume of waste sent to landfills, where decomposition is slower and produces methane, a potent greenhouse gas. Speaking of methane, certain microorganisms called methanotrophs actually consume methane as an energy source. These microbes are being studied for their potential to reduce emissions from landfills and livestock farms. If applied at scale, they could play a role in climate change mitigation strategies. Another application is in wastewater treatment. Here, communities of bacteria are used in activated sludge systems to digest organic pollutants. The result is cleaner water that can be safely released into the environment or even reused. Advanced treatment plants may also include nitrifying bacteria to convert harmful ammonia into nitrate and denitrifying bacteria to then turn nitrate into nitrogen gas, which is released harmlessly into the atmosphere. Now, in agriculture, microbes are proving to be valuable allies in sustainable farming. So-called biofertilizers and biopesticides rely on natural microbial processes instead of synthetic chemicals. For example, Bacillus thuringiensis produces toxins that target specific insect pests, but are harmless to humans and beneficial insects. Some startups are even developing microbial seed coatings, where seeds are inoculated with helpful bacteria or fungi before planting. These microbes assist with nutrient uptake, drought resistance, and disease protection. This can reduce the need for chemical inputs and improve crop yields in an eco-friendly manner. Microorganisms are also being used in bioenergy production. Anaerobic digestion systems employ bacteria to convert organic waste into biogas, a renewable energy source made mostly of methane. This approach is being used by both small farms and large municipalities to generate electricity and reduce fossil fuel dependence. There's even promise in the field of plastic degradation. Recently, scientists discovered a bacterium called Ideonella sakaiensis that can break down peat plastic, the kind used in bottles and packaging. Though still in the early stages, this discovery could help address the global plastic pollution crisis if developed further. It's worth noting that these microbial processes are not without challenges. The effectiveness of bioremediation or composting can depend on temperature, pH, and the presence of competing organisms. Also, introducing non-native microbes into an environment must be done cautiously to avoid ecological imbalance. In conclusion, microorganisms play a vital yet underappreciated role in environmental sustainability. From nutrient cycling and pollution cleanup to waste management and energy production, microbes are nature's engineers, working tirelessly at microscopic scales to maintain the health of our planet.
That is the end of part 4. You have now 30 seconds to check your answers. You have now 10 minutes to transfer your answers to an answer sheet.